Alrighty. Nomenclature. Now there's a fun word. Nomenclature. I can't even really take a guess about what it means. Well, actually, nombre. I mean, it kind of sounds sort of like name. I don't know what clature is though. All right, let's just get right into this. We'll figure it out. Yes, we will. It's like talking to an animal. Yes, we will. You're so cute. Simple ionic. Naming ionic. Oh, naming. Look at that. So I'm gonna actually write it down as a guess. Name. Naming ionic compounds that contain group 1 or group 2 metals is simple. Remember, that's the first or second column on the periodic table. The cation, which is the metal, always comes first and the name's unchanged. Then the anion, which is the nonmetal, usually, follows with an IDE, replacing the last few letters of the element name. The subscripts on the formula indicate the ratio of metal to nonmetal atoms needed for both to achieve a full valence shell. What? I'm going to come read that again after I look at this. So, for example, sodium and chlorine, metal comes first, sodium, it's unchanged, and then chloride. So chlorine becomes chloride. And then the formula is just NaCl. Okay. Magnesium and oxygen. Magnesium remains unchanged, then oxygen becomes oxide, and we have MgO. Calcium and bromine. We have calcium remains unchanged. Bromine becomes bromide, and we have, oh, there's a 2 here. Okay, this must be what they mean, the subscripts. The subscripts on the formula indicate the ratio of metals to nonmetal atoms needed for both to achieve a full valence shell. So I think what this means is that for every 1 calcium, there's actually 2 Brs in the crystal. Okay, try naming this. Come with it already filled out. You might want to pause, and you'll discuss it with your groups. Let's keep going in the reading. To go from the name to the formula, I guess this was formula to name, I don't know. Students need to know how to balance charges within an ionic compound. The total positive charge from the cations must balance out the total negative charge from the nonmetal anions. Oh look, here's our example. So calcium has a 2 plus. Remember, because calcium has 2 valence electrons, so it's going to lose them both. And bromine is negative, so I guess each circle is an atom, so we have 1 calcium, we have 2 bromines, so CaBr2. Magnesium forms a +2, oxygen's a -2, so we just need one of both. What about aluminum oxide? So aluminum forms a +3, it's got 3 valence electrons. Oxygen forms a -2. They're not balanced. I have more positives, so I'm going to add more negatives. So I add another oxygen, 2 at a time, because it's O2 minus. But now I need more positives. Oh, this isn't good. Now I have 6, I have 4. Actually, look. Okay, it actually works out. So here my formula would be Al2O3 to balance out all the charges. And I can get that just from aluminum oxide. Interesting, I don't need to know anything else. I can just predict it based on the charges. Let's keep reading. Transition metal ionic. Ooh. So remember the transition metals, if we have the periodic table, is the block right here, in between group 2 and the nonmetals. Ionic compounds that contain transition metals are a little more complicated. Good, we like a challenge. Because transition metals do not always give up the same number of electrons. Right, that's why we skipped the valence electrons. Skipped valence electron. A Roman numeral is used to indicate how many electrons they lose. A Roman numeral. Oh, so like X for like the Super Bowl and like V and stuff. So for example, iron loses 2 electrons when bonding with oxygen, so we get iron 2 oxide. So this would be Fe with plus plus, oxygen minus minus, so it's just one of each, no subscripts. Iron loses 3 electrons when bonding with oxygen. That would be basically the same as aluminum because it's aluminum 3 plus, so you get Fe2O3. These are very different formulas. So I can see how, depending on how many electrons iron loses, it's going to form a different type of ionic compound. Okay, so you should be able to name this one. You'll have to figure out what the charge is. We know there's only one, but we don't know how many pluses go in there. We know chlorine forms a negative, and there are 3 chlorines. So you should be able to figure out how many positives and figure out what the Roman numeral is. And then here, you should be able to figure out the formula from this. So try that. Come prepared with it to class. Pause if you need to, and then I'll annotate the covalent part. Let's keep going. Here's the covalent part. Naming covalent compounds is a little less complicated than ionic compounds because there are no charges to use to determine the formulas. Well, how do you figure it out then? Prefixes are used. So I know pre is like before. So this is before the word. Prefixes are used to indicate how many of each atom there is. A prefix is always used except for the first atom if there's only one in the molecule. And I remember molecule is a group of atoms. And then I guess these are all the prefixes, which you really need to memorize these. You won't be given them. So for example, H2O would be dihydrogen monoxide. So there's di is 2, dihydrogen, and then monoxide. I guess they're still doing the ide, it's just they're adding the prefix. OF2, notice there's no prefix here. And then difluoride. Alright, try to name this one, and try to write the formula for this one. Come with your brains, come with your binders organized, and I'll see you in class.